morning, all. This is a session meant for beginners. So we have some advanced statisticians here, so they may find a bit boring. But this is just meant for beginners on data management. So I'll take it as three separate sessions. So this is the part one of this session of data management. So why are we doing this? So importantly, when you're planning research, the first step is to plan your research. That means I've got a postgraduate will plan research, faculty will plan research. The second step is once you plan and then you've gone to the institutional review board and got it approved, you will collect data and you will create a database. That means you'll create the data for your study. The next step is you will analyze the data, you will collaborate with all your team members, and you will finally publish the data. You'll analyze and collaborate, then you will evaluate your findings, then you will share and disseminate your results with other people. The last step is to publish it plus reuse it. So if you store it and manage your data properly, you can reuse the data as well. So this is a very nice website for those interested, the Harvard Biomedical Data Management website, from which I've taken this nice picture. But it just tells a story of where we are. You can be in the planning stage, you may be collecting data, you may be analyzing, but really I'm going to talk about this planning and collecting data and creating data set. So that's really where we are going to be focusing on. So this is just to show you how data looks like. So I've just taken an SPSS. They have some dummy data sets. This is the accident data set. So you can see that it has got rows, and it has got columns. Excel spreadsheet also looks very much like this. So this is also called a database. So if you look any further, the same thing, you can look at here you got age under 21 and somebody has coded that as 1. Female, somebody has coded that as gender 1. And I'll talk about the other data as well. So any information you collect is called a data or a variable. So people sometimes get confused what is data, what is variable. Any information you collect is called data or a variable. And if you look at this, the rows represent one patient. So row 1 is one patient, row 2 is a separate patient. Each patient, there are 4 data points collected, 4 variables. So all the information about one patient is called a case. And here there are 6 cases. These 6 cases make up what we call a database. So data, case, data or variable are same. One case will have many variables. Many cases together becomes a database. So that's because this is a basic course, I'm going to start with that basic one. The next important thing is something called data dictionary. And I just want to use this SPSS form. There are two, if you look at this is called a data view, looking at the data actually. If you click at the bottom of SPSS or any of the data management software, you'll also have something called variable view, telling you all about the data. So data about data is also called metadata. It's not the data itself, it's the data about the data. Let's look at one. The first column here says age cat. It's not about the cat or mouse, but it's a short form for a longer variable called age category. So what is an age category? They've categorized it as under 21 and more than 21. So the age category is the first variable. The short form is called variable name. The long form is called variable label. Explaining the whole thing is called. So this is the variable name. This is variable label. Because all of us, I may put some other short form, I may just put it as age. The people will be confused, how can age be 1 and 2? So this is the short form of the longer form, which is called variable label. Now this age category, we have considered it as numeric because I have coded less than 21 as 1 and more than 21 as 2. But actually, in fact, you have categorized the data as 2 halves, less than 21, more than 21. So what is actually age is a number. But here they have categorized it as less than 21 and more than 21. But computer can't understand less than more than. So For the computer's sake, they have coded it as 1 and 2. I'm not showing the 2 here. So they have called the data type as a numeric type. Actually, it can only, with this 4 means it could have 4 points, like 1000. Actually, then you sorry, you need to have only one width point and no decimal point. They've got it correctly. This is called the coding of the data. When you categorize data as male as 1, female as 2, it's called coding. So this column is called values for coding. Sometimes if it's a very important variable, let's say we're doing a study and gender is very important. And for somebody, they'll record gender in the chart. I mean, it's impossible, but generally there may be somebody with gender wants to record it. Let's say some stillbirth study. Everybody is very upset the baby is stillbirth, but people forgot to record the gender. What will you put as a gender there? It is missing. Then people will put variance of 9. So they may put 99, 999. Generally, you can see that 1 and 2 fall a single digit. So if you put 9 as a missing variable, that's not good because somebody mentioned that there are many genders, transgender, this, and 9 is also one type of gender. 99 is clearly a missing variable. Then you can see here that you can see here that this is an ordinal measure. Ordinal means actually it is ordinal, meaning it's order 1 and 2, less than 21, more than 21. So that's the actual type of data that we have collected. So you can understand now that this is actually the data that we have collected, and this is data about the data. So when you collect data for your study, the first thing as a registrar, postgraduate, or as a faculty you must do is must know what all data you're going to collect. That's obvious. Nobody will know exactly what you want to collect. Then you must do this thing called a data dictionary. You can have it as an Excel spreadsheet, or you can have it in a paper form that this is how my data dictionary will look. So all of you must make a data dictionary. It must include the name of the short form of the variable, the long form which is called variable label. Are you going to categorize it? If you're not, is it a numeric or is it a qualitative data? Then the coding, if you have codes are only for categorical variables, not for continuous variables. Then what is the actual measure it is? You can see that gender has been coded as 0 for male and 1 for female. So it's called nominal. Nominal variables are categorical variables where there is no order. Who says 1 is male and 0 is female? There's no order you can put. But if you say less than 21 is 1, and then more than 21 should be 2. We can't mix up the order because an order makes a difference. That is called an ordinal variable. This is nominal where the ordinal order doesn't make a difference. Scale variables or numerical variables are just like height and weight. It's continuous, it can be any number. Okay, so now let me say something else. So accidents are just the number of accidents, and the base denominator was the population at risk. So those are continuous numbers. That's why they are called scale variables. So this is called data dictionary. So for people interested in making a data dictionary, these are the usual questions that people will say that should be in a data dictionary. The name. Name is a short form. What is acid? It sounds like, this is an acid story. I think it's accidents. But that researcher decided to put a short form as usually it should be not in large caps, it should be in small, and there should not be any gaps. You can put ACID or age and then a gap and put category. You can put an underscore if you like. Pop is what is pop? Who knows what is pop? Population at risk. So you must have all these. So that is the name. Short form is the name. The description is the long form. Variable units. Let us say that you collect data on weight. As an adult physician, you may collect it in kilograms. Pediatricians may collect it in grams. Neonatologists may be milligrams. So even though we say weight, we need to specify the unit in which it is collected because if you have data from many places, somebody will collect in kilograms, somebody in grams, somebody in milligram. And all has to be brought to one common unit. Either convert everything to kilograms or convert everything to kilogram. So the units is a very important one. Then relationship to other variables. Let us say you collect height and weight, and the statistician converts it to BMI. Then you can indicate that this is the mother data for the BMI. Coding. I told you coding. Generally, the rule of coding is you try to keep it as 0 and 1. whichever is the minority, which is less. Let's say death and dead and alive. At the end of hospital stay, are more people dead or alive? More are alive. The minority is dead. So you put dead as 1 and 0 as alive. That's a general rule, whichever is minority, dead and alive. Then that's coding. And you must write the meaning. You can't put 1 and 0, but without saying what is 1, what is 0. Is dead 1 or is alive 1? Issues with the data. Here we know that we have collected blood pressure from the OP chart. The issue is that most people tend to round off to the nearest 10. You never find in the OPD something like 122 by 78, sorry, 120 by 80. That's a known issue. So then later on, analyze the data and say 1 millimeter change in blood pressure is highly meaningful. It's not meaningful because we have already rounded it off when collecting it. So that is a known issues with that data. Anything else to know about the data? You can say that this data is very highly important to collect. This one highly important. There are some variables which you have to have, absolutely. There are two variables which you must have. Whenever you're doing a study, there's an outcome. Dead, alive, cured, not cured, discharged, not discharged. That's called the outcome variable. In research, it's also called the dependent variable or the dependent data. Without that, you can't have a study. If you don't have the outcome of half your patient, then what study is there? The second data which you must have is you're using gender to predict outcome. The gender is also called predictor variable. You're using gender to predict that. So you must have data on the predictor variable as well as the outcome variable. If you call the outcome variable as dependent variable, then the gender or predictor variable is also called independent variable. So you must be very clear with your research. I must have that information. So if you must write here, this data is a must have. So if it is not there, clearly I must measure, right, whether it was missing, meaning nobody ever collected that data. I can go back and find out from the patient if I can, otherwise it is missing. Missed data is the gender was there in the chart, but the researcher forgot to collect that information. So there are two things, missed and missing. What we're really worried about is missing data. So this is not from me. I've just given some example. For example, one short form of a variable was site, and the description is a two-letter abbreviation describing the name of the overall site where the sample was collected. Now, this is taken from this Caltech library where they have given a demo, a dummy form for data dictionary and an example of that. So, the postgraduates or anybody interested in doing research, this is a good website to see how to make a data dictionary. Another one, if you're interested in research data management, let's say you're doing a large study, and then managing your data becomes a big issue. This is a free website. Actually, the research data management workbook, again, this is also from Caltech. It gives you a large amount of information about managing your data. And if you're anybody online or offline listening, if you're planning to do a study, it's a good free website. And I've given and this is the lady who has Kristen Briney, who has written this chapter. It's updated after 2024 and it's free to read online. So it's a good place to read. Another blank template is, I'm just showing you some different templates because some template may work for you, some template may not work for you. And this Lauren Fegley has put up a template on an Excel spreadsheet. So if you click here, there is an Excel spreadsheet version of the data dictionary. So if anybody is interested, it looks like this. Variable ID, variable name, definition, source. So some people also give the source. So like if you collected the name of a patient, where would you collect the name for the CMC patients from? Would you ask the patient the name right now? Or would you capture the name from our clinical workstation? But then you make a wrong spelling, right? I've heard people spelling my name THANDOO, THUMBU. So usually the thing is you must collect the name, age, gender from an electronic data source, which has also been verified from somewhere else. So that's the important. The source means, okay, this information I got from electronic medical record. This information I directly collected onto my data collection form. This data I got from biochemistry lab. That's called the source of each data. So if you're going to a very detailed data dictionary, you can even write each information where that data came from. So this is another data dictionary template. This is from University of Pennsylvania, UPenn. And then there is another last one, which is again free to read, OSF, which is an excellent data site. And you can see that they have given you some different variable name, readable names, synonyms. It may also be called by something else. So for stroke, cerebrovascular accident, acute ischemic event, this. So what are the other names also? So these are all about data dictionary. And the last one is also from this ICPSR data set, which has also got variable different names given from this. From this, I want to talk to you about something called universal skip pattern. What is universal skip pattern? When I did my study, I did a study in ICU 1995, death in ICU. And at the end of it, I found that many women died of prostate cancer. How could it be? When I was entering the Excel spreadsheet at 1 a.m. in the morning after doing rounds, I made a mistake and entered it. So, what is the skip pattern? What should I tell my future self? If I put gender male, I should not be allowed to enter prostate cancer. If I put, if I put gender female, I should not have prostate cancer. If I put gender male, I can't have uterine cancer. So this is skip. So so then you must arrange the data in your data form in such a way that once you click name, some parts of the data set become blanked out. You cannot enter it. So it prevents data entry errors. Take it as detailed as you want, as simple as you want. All right, so that's about data dictionary. Any questions? So all of the postgraduate students doing research, first write down all the questions that you are planning to collect. You only know what you want to collect. Second, make a data dictionary. That is data about your data, metadata. That's called data dictionary. So let's go back to this. So let us say Amrita is asking an interesting question. That's your research question. You have a goal in mind. What's the outcome of interest? Very good. So then you have now gone to the ethics committee. What's the next step? Get the data. So you actually go ahead and collect your data. So then people are going to ask you, where did you get the data? Are you going to take every patient in medicine too, or a small sample of those patients? How did you choose the sample? What are data privacy issues? Did you get consent? How are you going to save your data in such a way that everybody in the whole world can't access the data? It is kept confidentially. The next part comes to explore your data. So once you collect the data, let's say in 6 months' time, you got your data, you've got a big Excel spreadsheet full of data, it doesn't mean anything. Then you start exploring, okay, how many men have I got? How many women have I got? How many with diabetes? How many without diabetes? I have blood pressure. What is the distribution? Does it look like a normally shaped blood pressure curve? Or the blood pressure highly skewed towards very low or very high? That's called exploring the data. Once you explore the data, you ask other anomalies. Hello, I've got a couple of adults with 2 kg weight, a couple of adults with 3000 kg weight. What happened when I was sleepy at night? Instead of 20 kilos, I put 2 kilos. Instead of 30 kilos, I put 3000. Maybe the decimal point got missed. So these are anomalies in the data which you need to explore. Model the data. Finally, you want to know, let's say that you want to know whether age predicts death in a general medical ward. So that is the modeling of the data. The data itself doesn't tell you the story. You have to do some statistical technique to tell you that story. That's called modeling of the data. So once you do the modeling and then you try a first model, then the statistician looks at how well the model works. Then on a subsequent data set, let's say another medical unit will say whether this model works in some other person's data. That's looking to validate the model. The last part is actually communicating this data. So that's a major part of research. If you look at the West, it's such a big idea now. Any major research project, it took 10 years, $1 billion study. Everybody's most interested in a single one picture called summary picture. Because that picture tells 1,000 words. Nobody nowadays sits and reads the whole 20-page article or the big manuscript. They just want to see in one picture what is this big study. So how you communicate your results is also a big part of the story. So this is a story of anybody's research. Right? This will put the whole thing in perspective. Okay, so asking a question comes from curiosity. It may also come from domain expertise. Maybe you're the expert in adult respiratory distress syndrome. Then you will also have something, we don't understand this area. Or it may come from your journal reading. So asking a research comes from all these things. So you can talk to your own brain, talking to experts, lot of scholarship is required. That's why very often people don't ask good questions because they don't read in depth to understand what are the questions that need to be answered. Getting the data, obviously, if you're doing a research, prospective research, you collect the data. But many often people get data from the internet. Let's say I want to know how many people today have Google CMC Vellore. How do I get the data? So I have to go to the internet and I have to get the data. Either I can write to Google and say, please tell me, or I can get the information. That is literally scraping the information from the net. That is called web scraping. Now that information on the net may have the CMC Coimbatore, it may have Chengalpet Medical College, which so I've spent a lot of time cleaning up the data. Querying databases, like I've collected a mountain of information. Much of the information is irrelevant. I want to get out the information I want. So for that, we need some software called Python, Pandas, and that's where we have to, that's more for the statistician rather than for the doctors listening to this talk. Then once you have collected the data, you need, oops, I do apologize. Once you collected the data, one needs to explore the data. If you collect data from the net, large amount of data, we need to get and then develop a hypothesis. Now, this sounds very unusual. You had a hypothesis, you planned a study, you collected data. But when people collect large amount of data from the net, that's called big data. Instead of this 100 rows and 100 columns, it is a million rows of million patients' data. Each human being have got 1,000 information. What are you going to do with the large data? You don't have a hypothesis. You just collected all the data. Then you can develop a hypothesis. Oh, now what am I going to do with this data? So it's a bit of an ulta. So that's something to keep in mind that sometimes you get the data, then you develop a hypothesis. You look for patterns in the data. The software which people use for that kind of thing, this Matplotlib and other software are available. This table you will never see in any publication. This table 0 or figure 0. Even a postgraduate student who collects data, you will first look at how many men are there, how many women are there, what's the average age. Those are the things you get used to the data. That you don't put in a publication finally. Publication finally looks at summary tables and summary figures. Those are called table zeros and figure zeros. Multiple will be there. So you're just getting a hang of your own data. So nobody in the world has seen it before. You and the statistician together start looking at it and trying to understand the data. Then you come to modeling the data, which we not taking a class today. We're trying to understand relationships. Is there a relationship between age and death? That is called regression. We can use software, machine learning, big data. There are many methods. And I've told you the software which are available. Lastly, how can I make a beautiful picture? Now, some of the skill is presentation. If you go and present in two first conference, you probably make a mess of it. But by the third or fourth conference, you know how to present. What should I not do? What should I do? How should I stand? How should I tell a story? What joke? When should I make a joke or not? That's communicating results. And then there are many software available now, which are listed here in the third column under tools to help you to make presentation. All of us are familiar with PowerPoint, but actually the art of making good presentation in PowerPoint is quite a huge skill in itself. Okay, obtaining the data. What is it of this? Okay, obtaining the data can be from various places. First step, from various databases and sensors. What are sensors? I don't know. I can't see anybody here having a smartphone, smartwatch, but you got. So I mean, you have now data readily available on your heart rate, blood pressure, walking, gait, blah blah. All that sensor information can also be got. You can also get data from databases which are available on the net. So this is a word which you must all get used to, application program interface or API. These are programs which get the information from net into your computer or from the sensor into your laptop. They are called APIs. They're from online platforms. Then you must ask the question, hey, I've got this information from various sources, from sensors, from database, from here and there. Is it the right information? Have I collected what I set out to collect? and gather data relevant to the problem we're trying to solve. Okay, now I've got the data which I really want. So avoid wasting time with the efforts that follow. So the most important thing is if you got the wrong data, however clever you are, your analysis will flop because you started off with the wrong product. Like if you're a great cook, but you got terrible ingredients, okay, you can salvage some of it, but mostly you can't salvage. So getting the good data is the really good part. Some people are thinking about their lunch. The next step, you got all the data, the correct data. The next step is called data cleaning. I put a picture of a washing machine here. But literally, that's what all the statisticians do, right? And I'll show you how much time they spend doing that. That's called data cleaning. Some people call wrangling. Wrangling is like squeezing it out and getting the good quality data out and checking off the bad values. So looking for missing values. Missing values very important. Duplicate values. Hey, the 5 consecutive patients have got blood pressure 110 by 80. Maybe somebody just by mistake cut and pasted the same value for the next 5 patients. Other errors are also possible. So this takes a lot of time. So our statisticians say I am. They're not yet had the talk, the experience of this. But if you go to our biostats department, most of their time is not doing fancy analysis. 90% of their time is spent in cleaning up large data which people are giving them for errors and all that. So getting the data to be usable and reliable, that's really the name of the game. The next step is called data exploration. But people also use the word EDA. It's exploratory data analysis. I told you about table zero. This is the next step. And a statistician and clinician will be spending a lot of time understanding the main data, how it looks. What patterns are there? Patterns meaning I may look at age and gender. I've done a tabulation. I've got age, I've got gender. Hey, whether men are older, women are younger. Is there some pattern? Depths are there. This is more in men or women. That may not be my final story, but I'm trying to look for some hidden patterns in the data. Right. So that's an important thing that one must do. We don't have time today, but it's called univariate analysis, bivariate analysis, multivariate, or nowadays people call it multivariable analysis to understand your hypothesis. The last part, once you're done exploring the data, is modeling the data. That is trying to find the real story. You set out to find whether age predicts death. That final answer to that question is called modeling the data. That modeling the data could be done by machine learning. Now everybody's into machine learning. But actually, you find that it's a little bit overhyped. Simple statistical technique does mostly what machine learning does. Of course, somebody may have fits listening to me saying that, but it's true that you can actually get away by doing simple statistical techniques for most people. One does not really need to go and kneel down to machine learning. What are you trying to do? You're trying to predict outcomes, death, and the relationship. Does age predict death? So, depending on the problem, it could be predicting, like predicting the future. That means anybody in the future who was older, who comes to the hospital, for example, in COVID, the last 2 waves, we knew that all the older people were highly likely to die. That actually led to huge policy changes. In the UK or some other countries, for example, if you're above some cutoff, let's say 70, and you came with severe COVID, you will not be offered ICU care or ventilator with a very high chance of dying. Let's keep the ventilator for the younger patients. It does lead to a prescription what to do. Sometimes it's just describing clusters. For example, you're running a shop. Hey, I've got pizza, I've got burger, I've got samosa, I've got vada. Now, who are the kind of people who are going to be buying samosa? Who's going to buy pizza? Oh, younger people are buying pizza. But they only come during break time, which is 10 o'clock, 12 o'clock, and 4 o'clock. Around that time, I make sure that my pizza is available. Rest of the day, it's all samosa and vada. So this kind of clustering of data, understanding human behavior also leads to something, but there's another aspect, modeling the data. Finally, interpreting the results. Now, you may get some results, but what does it mean? Age predicts mortality. Is it really age or is it biological age? So some people are, you find some 8-year-old people, they look like they're 40. You look at some 50-year-old, they may look like they're 80. So is it age or is it actually diabetes which is happening at older age? It is a real story, not the age. So you must have some person who is good in science, understanding to explore what is the meaning of your results. Your results are your results. What does it mean? Interpreting. So that's called knowing versus understanding. I know that age predicts that. Very good. But it may not be the true full story. Is there some underlying story? Lastly, communication. Now I can put a graph. If my audience is statisticians, math people, understand, a graph may be good. But if I'm going to the policy maker whose background is social science or something, you will look at the graph and go, what is this gobbly group? I can't understand anything. So you must communicate your results not to yourself. You must know your audience. So communication actually the first thing is who is the audience I'm communicating to, and then I must therefore communicate that results to them. So let's see. This is a nice paper which I found. It was published in 2016 in this Forbes. So, of all the steps which I took so far, what do you think data scientists means doctors and statisticians and everybody? Where do we spend maximum time? So, let's say collecting data sets and dark green is only 19% of time. Cleaning the data, 60% of time. Building data, training the data sets, refining algorithm, which is what everybody thinks the statisticians are doing. I'm doing high level computing, I'm a genius. That's only about less than 10% of your time. So most of the time spent by almost everybody is cleaning the data sets. Now, which did they hate the most? What is the least enjoyable part of data science? 57% of people said the least enjoyable part is cleaning the data set. So it's very important as a residents here was speaking here today, or as young statisticians, that you get the data right the first time. If you get high quality data the first time, fantastic. So we run some workshops. I'm pimping for that, the Data Manager, RedCap. Those software make sure that when you collect the data itself, it is high quality. Then you don't have to spend much time in cleaning up the data afterwards. So you can almost directly go to analysis. Whatever you do, there'll be some errors. So never think something is 100%. But at least it's far better than having this. If you could spend much less time cleaning up your data, then you can do much more time doing this, which you really love to do. Right? Okay. So now data science, data science, data science. What is the data science? Because that is, anybody recognize this gentleman? Common Man, R.K. Lakshman. That's how he actually looked at. That is the Common Man cartoon. Possibly that's the icon is sitting there. That is R.K. Lakshman. So the team, I'm just showing it's a team. So who is the data science team? Doctor, information specialist, a doctor who understands data, data analyst, somebody who can analyze the data, database manager. If you're going to manage a large project, there should be somebody who can manage the database itself, this computer, the hardware. Then you have the statisticians, quality assurance. Somebody makes sure that the data is high quality, the process is good quality. Then you have computer guys. You must know that hey, this is the RAM you need, this is a ROM you need, and this is the whatever else. I can't even explain all those things. So the IT guys, all this together is data science team. Some people say I'm a data scientist. There may be any one of these and claim I'm a data scientist. Don't believe that. It's a team. You can't have one fellow saying, you're not going to that. The 1984 story about the animals. Each one claims that they are the king. Right? So that's what we should not be. It's a teamwork doing data science. So it's a team sport. Every player is important. So now people use this catchword, oh, the major player in data science. If the doctor didn't collect the data, if they didn't have a hypothesis, collect the data, or the patient didn't arrive to the hospital for you to collect the data, or the statistician didn't know how to clean the data, or the IT support was very poor, everything is gone for a six. So the whole team is equally important. There's no one person more important. This knowledge is also called corporate knowledge. Why I'm using these words is you suddenly hear these buzzwords as you grow up. Oh, corporate knowledge, players. Just a human being. Fancy words, who's a big player in this team? Equally important team. Corporate knowledge is the knowledge that everybody has together. Only when we share the knowledge, it's called corporate knowledge. If I have the knowledge and say, I won't see, let me see Andrew failing. That's not corporate knowledge. That's a useless knowledge. It doesn't contribute actually to anything. What does the administration think? They may think that, budgets, cost must be reduced. Hey, you're going to introduce this new test. Will I make money or I lose money? The clinician will be thinking, hey, this new test may add to my work. On top of ordering CT scan, normal order MRI, schedule it, run around getting it. The intern will be almost like to be put. So that's clinical workstation. History and concern of patient, often the bottom of this team sport is the patient. Because ultimately, all healthcare is to get patient better. So increasingly now, when you have data like teams have a patient, what is your opinion about this whole thing? Hey, you collected all this data from the net. Have you ever thought that Google collects your information and uses it to market you without your permission? Every time you click something on the net, somebody is collecting that information and selling your information to somebody else. Patient may also think, you collected all this data in CMC, but you never asked my permission to make some AI model or something and sell it to somebody else. So you must also involve the patients in this corporate team sport. Okay, so how are we doing for time? We have 10 minutes more? Yes. Okay, we have about 10 minutes more. So data preparation and exploration tools. So I'll just take 10 minutes more, then we'll stop. So the first step is defining the problem. So this is going more into depth now. I gave an overview. The next part two, which I'm just starting today, will continue the next Saturday is data preparation and exploration tools. First is hypothesis. Where does hypothesis come from? Reading a lot, experience with the patient, journal clubs. Very rarely is like, I wake up one morning and suddenly the apple falling inside gravity. Actually, he must have thought about it deeply. So many people saw apple falling, but he didn't think, all of us never thought gravity, but he thought gravity because he had some background knowledge. The hypothesis comes from that. Second, it's important to healthcare that hypothesis must be important to somebody, either the organization, the patient, or the team. Administration may think that, too many heart failure patients are getting readmitted, and we are wasting a lot of money and time on that. Maybe we can reduce that. They are more interested in the finance, legal liability. Patient is like, this hospital doesn't take care well. Every second month I'm getting admitted for the same problem. Looks like they're trying to make money off. Clinically, patient may say that patients with asthma are admitted to emergency room. Maybe our asthma inhaler technique is poor. We should not be having so many asthma exacerbations coming to the emergency room. And there's increased mortality. So the hypothesis may have different perspectives. The perspective of administration, a doctor, a patient may vary. Just be aware that each person has got a different take on the same problem. There must be a primary hypothesis and possibly a secondary hypothesis on a new problem. So, without a hypothesis, some people collect large amount of data and then say, let me see some p values here. Let me see that age is more in women. That's not a hypothesis. It just so happens that your data is collected more women who happen to be older. But then the p value is significant. And you publish that as a major research finding. Women tend to be older in this part of Canada. But nobody asked the question. You just found some association you published. What did you do? You changed the p values. So this is also called p hacking, data dredging, different words, data witch hunt, mining the data endlessly. The same as gentleman said, if you torture the data long enough, it will confess to anything. I'm sure if you torture the statisticians long enough, they'll also produce a p-value. That's the most important thing. Right. However, having said that, there are some kind of data which is emerging, big data. You collect mountains of data and you tell the computer, the AI program, find associations, which I didn't think about earlier. Without any hypothesis, you purposely go into the data and say, I just want you to find some relationship. Having the computer produce many such relationships, the scientist or the clever doctor must decide which of those associations is meaningful and which can be explored further. There are some hypotheses the AI kind of done, which is exploration of large data sets, which may have some things which come up important. But by and large, we are still in this, starting with a hypothesis, then we collect the data, then we either prove our hypothesis or we disprove our hypothesis. So those are the ways we go about research. The next one is locating and retrieving the data. There are many challenges in locating the data. Finding the right data, if you're doing a prospective study, you know who are the patients who are going to collect the data, how you're going to sample those patients and get them. You're going to have a data entry form. You're going to make sure the data quality you collect is good. But very often, many of the research you do are not prospective, it is retrospective. When the data is lying somewhere, that is a major problem. It must answer your hypothesis. First, the data might not exist. If you want to know the effect of blood pressure or cardiovascular outcome, or the effect of height and weight, very often in our outpatient department, we don't collect height and weight on every visit, unless you have a nurse who's doing it. And finally, say, I can't do this research on height and weight and outcome because 50% of patients have missing height and weight. So that's an important thing to consider. The data may be in a challenging format. Maybe the data is, previously in CMC, we used to write in hand. Nobody can analyze handwritten information. Somebody has to take the handwritten chart, decipher it, enter it into Excel spreadsheet. Then we started scanning the data. The scan is because an image in a PDF file. Now that is zero. That's equal to just reading a handwritten text. So we have to go through mountains of PDFs and then try to decipher the information. And people's handwriting is bad to worse to very worse. So you have to decipher the handwriting. So that's a challenging format. How do you get that information into you? Clinicians' notes tend to be very poorly done. Sometimes the data is located in a workstation. Sometimes you need a clinician to tell you what the data is meaning. A statistician looking at the data may not be able to understand what this works. Where is the height? Where is the weight? Where is the clinical features? Where is the diagnosis? Because some people write the diagnosis on top of the chart. Some people put at the end of history and physical. Some people don't write a diagnosis at all because it's very implied to them because they know what the diagnosis is. So that somebody must help you to interpret where the data is. So sometimes as an analyst, you employ somebody who's going to help you to do all this process. So then there's another word which all of you must learn. It's called ETL. Extract, query the data, question, extract the data, take the data out, let's say from an Excel spreadsheet, transform it to what you want, and load the data onto your software. So this extract, transform, and load is also called ETL data. Just to teach you that there are fancy words which people throw around. Basically, as a postgraduate student, you will go through a chart, then somebody wrote some squiggle, you will interpret what that is, you will put that into your paper form, the data entry form. One day later, you put that into an Excel spreadsheet or some other data entry program. All this process is basically ETL, which fancy word for that. Or it comes from something called a data warehouse. So I just want to give a little explanation of what is called data warehouse. Right? So this is just to teach you some new concepts. So there are sometimes what is called complex data sources. It's not unusual that data comes from multiple locations. Let's say that I will say you want to collect history and physical from medicine to patients. Where will you get that information? From the history and physical, but already discharged patients. From the discharge summary, it is in the clinical workstation or electronic medical record. If you want to get the X-ray findings, where will you get from? So Centricity is a radiology website. So you may have to go to another website to collect information. If you want to get biochemistry data, you may go to labs to collect the data. So these kind of data have to come from different places and be merged together in your research protocol. That's an important thing. So there are different formats. The X-ray is not reported, test X-ray. It's just in an X-ray format. You have to read the data and put it inside here. So processing the data from various original sources, first locate it and then processing it is very critical. The pertinent data may be put into a large database which is called enterprise database. It's a large database of everything which I want. And then from this large data set, there's something called an enterprise data set or a data mart, which is my final data set for analysis. These are some fancy words you must learn. A large data set of what I want. Then exactly what I want is called a data mart. And the people who do all this information are called data scientists. Remember, a data scientist is a team. But sometimes only the person who gets this information for you is called data scientist. Get used to the word SQL queries. SQL stands for Structured Query Language. So it's a standard language for storing, manipulating, and retrieving data in databases. How to get all the information from various sources and put it into one? That technique is called SQL. So people, I do SQL queries. It's not a rocket science, it's just one fancy word. For teasing out the data, and sometimes the data is several thousand rows. So it's huge volumes of data, you're going to get them all. If it's in millions, it's called big data. Big data has got 6 V's. Anybody knows what the 6 V's are? Volume. Huge volume. Velocity. If you look at CMC's database workstation, every day 10,000 pages come. The volume of data and the velocity of data. Third V is veracity. Some of the data may be good quality, some of it may not be. So I would ask your homework to find out the rest of the 3 V's which make up big data. So big data means very complex data. Half the data may not be good quality, half the data may be good quality. So okay, I'll stop with this today. It's 12 o'clock. We should stop at time. And I'll take the next session on the next Saturday. We'll go on a little bit of this. Just want to try newer concepts to teach about it. Are there any questions on today's talk? Newer words, newer concepts, that's all. Thanks for coming. Are there any questions from the online audience? Shall we close for today? Okay. Thank you all.